In today's video, we're going to look at factoring trinomial expressions. So as a reminder, a trinomial is going to be a polynomial expression that has three terms. And usually the ones that we're going to be looking at are of this form, ax squared plus bx plus c, where we've got our highest exponent variable, our x squared, coming at the first term, middle term goes one down, last term is just our constant, or technically x to the 0. And most of the functions or most of the expressions that we're going to look at will have this format, but we may have, additional constants multiplied in or additional variables, so things to keep an eye out for as we're working. And so let's kind of derive a pattern for how we can factor these out by approaching this like a factor by grouping problem, like what we did last unit. And then we'll see what kind of patterns or what kind of organization we have in there that can then help us with any of our future problems. So let's look at example 1. We're going to factor x squared plus 7x plus 10. And so the first thing that we're going to do to turn this into a factor by grouping problem is we need to figure out, well, how are we going to separate out that middle term so that we can factor it by grouping like we did last time. And so what we're going to do is we're going to actually multiply our a and our c, our coefficient for our first expression, which again, if we don't have an expression or a value written out in that coefficient spot in front of any term, don't forget your implied coefficient is always 1. And we're going to multiply that with our c term coefficient, aka our 10. And so a times c, 1 times 10, would equal 10. And so then our next step is, let's think about factors of 10 that will work with trying to create that middle term of 7x. And so what are some of the ways that you can multiply to make 10? Well, we can do 1 times 10, or we could do 2 times 5. And again, order is not as important because when you multiply, does order really matter? No. Order for multiplication is always commutative. So then what are the sum of our factors? So sum meaning adding, 1 plus 10 gives us 11. 2 plus 5 would give us 7. Wait a second. We're trying to make a 7x in the middle. So let's think about, could we separate that out with a 2 and a 5? Well, yeah, we could rewrite that as x squared plus 2x plus 5x plus 10. Same expression, just separating out that middle term. So now let's apply our factor by grouping that we did last lesson. So first group, x squared plus 2x, we have an x in common, and we're left with x plus 2 after we factored out that x. Same thing, 5x plus 10, what's our factor that's in common? Well, they both have 5, technically a positive 5. Factor that out, we have an x plus 2, and the x plus 2 matches from both groups. So we have technically an x plus 2 in common, and our leftover was x plus 5. And so that is our factoring using the grouping method, but let's think about what implications this has with comparing it to that trinomial that we started with. So here's what we want to check out whenever we're doing these problems. And this is kind of our shortcut method, what we would call guess and check. We need to use that kind of brainstorming step to guess at what factors we're going to use to put in these spots, the 2 and the 5, so that when we multiply everything back together again, we still get that 7x in the middle. And look specifically at what happens when you multiply your middle two terms, which gives us a positive 2x, and your front and last terms, which gives us a 5x. Well, if I put those together, 2x plus 5x gives me that 7x that we were trying to find in the middle. And that's how I know that this factoring is correct. I can check the first two terms as well. X times x gets us back to that x squared. And then the last two terms, 2 times 5, gets us back to the positive 10. So everything multiplied back together again would still take us to that trinomial. And so what we can do to kind of save ourselves a little bit of time, instead of turning every single one of these into a grouping problem, well, let's kind of guess at the different factors we can use and then check using the multiplication. So let's try out a few problems with this. And again, we're going to start out pretty straightforward, where we're just starting with an x squared, or just straight variable squared without a coefficient. And then we'll start adding some coefficients in there in that leading term and see what happens. So here we go. Next example. we are going to factor out our expression, and actually that should be an n. I think the new version that you have saved does have an n in it. So n squared plus 2n minus 24. So again, leading coefficient of 1. And so let's think about those different factors of 1 times negative 24. We're going to have to take our negative into account here. So what are some of the different ways we can multiply to make a negative 24? Well, we could do 2 times 12, but because we have a negative, one of those values needs to be negative. So either that could be the 2 times negative 12 or negative 2 times positive 12. And so these are kind of all the things we need to brainstorm about, the signs and the factors. So how else could we multiply to make 24? Well, how about 3 and 8? Again, one needs to be positive, one needs to be negative. We could also do 4 times 6. Again, one positive and one negative. And so what we need to do is figure out, well, which one of those is going to get us to that middle term of 2. So I'm looking for which one, when I add my factors together, gets me that 2. Well, for positive 2, that means I'm looking at that very last one all the way at the end of my list. So let's plug those in, check our values, see if it works. Okay, n squared, well, there's only one way to get that. I can do n times n in the front of my expression. Okay, I chose negative 4 and 6. Okay, so negative 4 and positive 6. So now let's check that our multiplications work. We already know that n times n is n squared. We already know that negative 4 times positive 6 gives us the negative 24. So we just need to check for that middle term. So we have a negative 4n and a positive 6n. And when I add those together, so negative 4n plus 6n gives me a positive 2n. So everything checks out. And that is indeed our factoring. Alrighty, let's try example 3. So are you noticing anything about this example before we start factoring? Think about what we did last lesson. We do this every time we do grouping, but it was actually the first thing we looked at last time. Look for a GCF. Whenever you are factoring any expression, always check to see, do you have a GCF that you could factor out to make your life a little bit easier? So I'm going to start with that. Actually, let me change over to purple again. So every single one of those values is even. So let's factor out a 2. So we are left with a squared plus 11a plus 18. And so now I'm just going to factor what I have in the parentheses and use that. Just make sure at the very end, copy that 2 down in front of your factors. Just make sure you write it out. So again, let's brainstorm. We don't have to worry about negative signs on this one. So 1 times 18. Again, 18, brainstorm on your different factors. Everything's positive, so less to list out. We could do 1 times 18. We could do 2 times 9. We could do 3 times 6. Which one of those is going to give us a middle term of 11 when we add them together? Yep, 2 and 9. So let's check it. A squared is a times a. 18 is 2 times 9. Everything was positive. So again, check your multiplications. So 2 times a is a 2a. A times 9 is a 9a. So we would get 2a plus 9a is 11a, which checks out for that middle term. But don't forget, what did we have out front? We had the 2 that we factored out very first step. So that is our final answer, 2 times a plus 2 times a plus 9. Alrighty, next problem. X squared minus 4x plus 24. So no GCF to worry about on this one. We want to brainstorm on 1 times 24. But what do we need for negative signs? If we're trying to make a negative term in the middle, then that means we're going to have negative signs involved in our multiplication. And the only way to multiply things out to make a positive 24 is if both terms, both factors, are negative. So again, let's brainstorm some factors. We could do -1 times -24. -2 times -12, -3 times -8, -4 times -6, and then we start repeating our factors again. So which of these could we add up to make a -4? Well, wait a second. We have a problem here. None of these add up. So is it possible that we just don't have a factorable expression? Absolutely. Since none of those factor pairs are going to work, this is not factorable. Bummer. Alrighty, now would be a good time to pause the video and try out example 5, and then start them back up and see how you did. Alrighty, so example 5, again, no leading coefficient on the n squared, no GCF. So all I have to do is brainstorm on 1 times -56, aka -56. And so factors that I could use with that, I could do, let's see here. Well, 56, I think that's, well, it's an even number. So I could do 2 times, well, what's half of 56? Let's see. Half of 56 is 28. Yeah, doesn't matter what combination, if it's positive or negative, I don't have a difference of 1 to make that middle term, so I know I can eliminate that one. Let's see, factors of 28, well, that's 4 times 7, so what about a 4 as a factor? And indeed, if I divide that out, 56 divided by 4 actually gives me 14. Again, they're too far apart. No matter what order I subtract those in, I wouldn't get that -1. Well, let's try 7. Well, 7 times 8 is 56. And hey, look at there. There's our difference of 1 that we're looking for. Again, we need to make sure that we've got one positive, one negative. So our options are -7 times 8 or 7 times -8. And the only one that when we add them, we make that -1 for that middle term would be 7 times -8 or 7n plus -8. And so those are going to be our factors. So n plus 7 and n minus 8. And again, we can double check those. So middle term is positive 7n, end terms are -8n, and 7n minus 8n equals the -1n that we were looking for. Alrighty. So now let's look at what happens when we don't have 1 as a leading coefficient. And so I'm going to, again, kind of take a page from this check or guess and check. I'm going to guess at what factors need to go in my parentheses, and then I'm going to check my multiplications to see what works. Now, this is going to go a lot more smoothly when we have prime numbers, but we could use this for any combination of values. So let's check one out and see how it looks. So example number 6. So again, we're going to think about first, well, what can we multiply to make -49? And what can we multiply to make that 3 in front of that d squared? We are ultimately trying to fit this into the pattern of 2 binomials that we're going to multiply together. So let's see here. What's the only way that you can multiply 2 numbers to make a 3? Well, 3 times 1. It's a prime number. So automatically I know that the first 2 values in each binomial, one has to be a 3D, one has to be D. So all I really need to play around with is what's going in that second grouping. So -49, well, wait a second, 49 is a special number, isn't it? It's 7 times 7. Very few factors that we have to worry about because, hey, wait a second, they're both 7. But if we want to make this negative that we had in that last term, that means one has to be positive, one has to be negative. And we just need to test out, well, which order is going to work. So we could either have a +7 there and a -7 on that one, or we could have 3d -7 and d +7. So we need to check which one actually works. So again, multiply your insides and outsides. Inside gives me 7d, outside gives me -21d. 7d minus 21d equals a -14d. Nope, that one doesn't work. Bummer. So that means the second one should work, but let's check to just make sure. We have a -7d, a 21d, -7d plus 21 equals a positive 14d. That's the one we want. Awesome. Okay, Example 7, very similar. So again, we don't have huge numbers to work with, but we might have some more combinations to work with on here that we need to check. So I'm going to have a few different checks on this one. So looking at 4n squared. Well, there's a couple different ways I know of to multiply to make 4. One that comes to me first is 2 times 2. So let's try it out first as 2n and 2n. Excuse me. Let's fix that. 2n. And it's the same sort of thing with the 4 at the end. But noticing I've got a positive 4, but I have a negative for that middle term. I know I'm going to have to use negative times negative to make that positive 4. So let's try negative 2 and negative 2. So double check it. Insides and outs. Inside negative 4n, outside negative 4n. Negative 4n minus 4n gives me negative 8n. This one doesn't work. Bummer. And there's no other way to arrange it with 2's in there. So let's maybe try this with a 4n and an n. Let's see what happens. Again, this is why we call it guess and check. We're guessing at what values can be put in there, and we're checking by doing the multiplications. So let's try it with the 2's. Let's just change one thing at a time and see how it works. So let's use a negative 2 and a negative 2 on this one again. So again, double check it. I'm going to do green this time. So negative 2n and negative 8n. So negative 2n minus 8n gives me a negative 10n. Closer, but not quite. So what's the only other thing that we could play around with? Yeah, instead of using negative 2 and negative 2, let's change over to 1 and 4 on this. So let's try out 4n minus 1 and n plus, minus 4. And again, if this one doesn't work, there's only one other one we could check, 4n minus 4, n minus 1. But again, let's see how this one works. So we have a 1n or negative 1n. We have a negative 16n. Negative 1n minus 16n gives us negative 17n. This is the one we want. So this is our final answer. 4n minus 1 times n minus 4. Alrighty, so far the numbers I've given you are pretty straightforward, but as you look at number 8, any worries? Well, I'm looking at 28 and 25, and I might have the same kind of scenarios going on, but 28, I've got a lot more factors to use. 28 is, well, 1 and 28. I could use 2 and 14. I could use 4 and 7. And then I have all possible different signs that I have to work in with the 5. So with this one, I want to remind you, don't forget, factor by grouping can be a good backup method, especially if you notice you have larger values where your factors, maybe you've got a lot of different combinations to test out. So just as a reminder, let's actually go ahead and do this one with factor by grouping. So here we go. So we need to make that 60 in the middle, and we're going to brainstorm with 28 times negative 25. And so to save you a little bit of time on the multiplication, you plug that in your calculator, you will get negative 700. Again, big number, but what's the first thing that pops into your head with this? Well, let's see. I could do 7 and 100, whatever combination of positives and negatives, but I could also do 70 times 10. And so which one of those do y'all think you're going to have when you add or subtract them? And again, we're going to have one positive, one negative, so we need to decide on that. Which one's going to come out to 60? Well, it's going to be some combination of the 70 and 10. If I actually add 70 and subtract 10, that would do it. So let's use that to just rewrite that middle term and then factor by grouping. So here we go. So let's rewrite as 28p squared plus 70p minus 10p minus 25. All right, so 28 and 70 have a common factor of 7. Actually, I think we can go even bigger. Let's see. I know 14 is a factor of 28, and so 70 divided by 14 is 5. 14 and p Those are my common factors. That's my GCF for my first two terms. So I'm left with 2p plus 5. Negative 10p and negative 25, again, what's their GCF? Negative 5. Factor that out, and we are left again with 2p plus 5. And so then by factor by grouping, we have 2p plus 5 in common and 14p minus 5. Again, factor by grouping still works on this, and you can always use it as a backup plan. If you are worried or if you start brainstorming and you get stuck and you can't figure out which factors, try switching over to factor by grouping. Alrighty, example 9, let's factor 2a squared minus 5a minus 6. So nothing in common with any of these. We don't have any GCF, so let's just jump right in and start guess and check. And this is kind of nice, having the 2a out front, or 2a squared, prime number, so I know no matter what, I'm starting with 2a and a. And then I just have to figure out what am I going to use for that last term. And so this is one, again, may take a little bit more with the brainstorming. And actually, let me take this and move him up a little bit. Oops, multi-select, there we go. Let's move that up a bit. Okay, so with negative 6, trying to figure out what's going to go in those second two spots. Again, brainstorming on negative 6, I could have positive 1 and negative 6, negative 1 and positive 6. I could have positive 2 times negative 3, negative 2 times positive 3. So let's actually test these out and start plugging them in. So let's see, let's start with plus 1 and minus 6. Test it out. Okay, we have a 1a, negative 12a. Do those add up to give you a negative 5 in the middle? Nope. Try the next one. Okay, 2a minus 1, a plus 6. Let's see. So negative 1a, we're going to run into the same problem. These are just too far apart to make that difference of negative 5. So that means I'm going to try a different one. So let's try the 2 and the 3. So 2a plus 2, a minus 3. So we have a 2a and a negative 6a. Huh. That doesn't quite work, does it? And wait a second. If I flip-flop these, is that going to make any difference? We'll have, a negative 2a and a positive 6a? Huh. Let's try rearranging our order. So instead, let's do 2a and minus 3 and a plus 2. Let's see if that gets us anywhere. So we have a negative 3a. Oops, I left off my parenthesis, didn't I? And we have a positive 4a. Yeah, we're not getting any closer. Our values just aren't going to make that negative 5 in the middle. So unfortunately, this one is not factorable. That happens. And again, you could always, if you want to, pause the video, try it by factor by grouping, and see if anything else matches up. Okay, 2 more problems. We're going to do one together, and then you're going to try one on your own. Here we go. Number 10, factor 6x squared y minus 15xy minus 36y. You got some extra stuff in here. What should be your first step every single time you do any factoring problem? GCF. So what's in common between all of our terms? Let's see, we can definitely factor out a 3, and we also have a common y. So let's factor out a 3y. We are then left with 2x squared minus 5x minus 12. Much easier expression to factor out. We even have a nice prime number out in front. So let's start guessing and checking. I'm going to start with 2x and x. I need to think of my factors for negative 12. Alrighty, let's see. I have 1 times 12, which I have a feeling is going to be too far apart. Let's see, we have 2 times 6, and we have 3 times 4. Let's try 3 and 4. And we need to have one positive, one negative to make the negative 12. So let's do a positive 3 and a negative 4 and see what happens. So again, test your multiplications. So we have a 3x and we have a negative 8x. Is that going to give us a negative 5 in the middle? Hey, wait a second, I got it on the first go. That doesn't always happen, but double check. So if I had my signs reversed, I just would have, change it to a negative 3, positive 4 if I needed to, but this one seemed to work. So that means my final answer, I'm going to use the 2x plus 3. I'm going to use the x minus 4. And I don't want to forget to copy down that 3y, the GCF that we got all the way at the beginning. Alrighty, so wouldn't be a bad idea, pause your video, try out number 11, and then you can start it back up and see how I did. Alrighty, so example 11 also has a GCF. Everything's an even number. So let's factor out a 2. That's our biggest number we can take out. Leaves us with a 2b squared plus 5b minus 12. Wait a second. That looks really, really close to what we had in example 10, doesn't it? The only difference is we have a positive 5 instead of a negative 5. So we can actually use the work that we just did. When we used a positive 3 and a negative 4, it ended up giving us that negative 5 in the middle. So let's flip-flop it. Let's try 2b minus 3 and b plus 4 and see if that works for us. So check your multiplications. We have a negative 3b. We have a positive 8b. Negative 3b plus 8b. Yep, that gives us the 5b, the positive 5b that we want. So that means our final answer, it has our factorings negative 2b minus 3, b plus 4. And don't forget to copy down your 2 that you factored out as GCF. Let me know if you have any questions whatsoever, and we're going to keep practicing these by applying them to our next 2 classes. So we will keep practicing with this factoring.